Okay, this is just a review of what valence shell electrons are and how to find them. So let's start with something, an example like boron, which is right here. If it's electrically neutral, so saying it doesn't have a charge up in the upper right hand corner as a superscript, we know that boron has 5 electrons. How do we know that? Because this tells us the number of protons. So there's 5 protons in boron. There's no charge, positive or negative, so the number of electrons has to equal the number of protons. We're not worried about neutrons. The only way we can determine how many neutrons we have is if we're given the mass number or told exactly how many neutrons there are. So let's start by determining how many electrons are in the valence shell. So valence E. Our rules for filling our orbitals is that the first orbital can hold 2 electrons. And every orbital past that, so to the second through the 7th shell, can hold a max of 8 electrons. We are going to fill the first electron shell before we move on to the second. The second one has to be filled before we move on to the third, and so on and so forth until we run out of electrons. So let's draw boron. We already found out because it doesn't have a charge that it has 5 electrons. This ring I'm drawing is one of the shells I'm talking about. This is the first energy shell, and we know that it can hold 2 electrons. So I'm drawing those as dots. We're trying to keep going and filling shells until we hit 8. Every energy shell past the first shell can hold 8 electrons, but boron only has 5, so we just fill it 3, 4, 5. So we have 2 electrons in our first shell, 3 in our outer shell right here in our second shell, so we get our 5 total electrons. The shell that contains the electrons, the outermost shell that contains this, is called the valence shell. So if a question asks you an electrically neutral, meaning there's no charge, boron atom, how many valence electrons are there? You would say 3. Because this is the valence shell and there's 3 electrons in it. Okay, let's do another example with something that's neutral. So let's pick sodium. So here's sodium up here. We look at the atomic number right here, and that tells us how many protons. So sodium, without a charge, has 11 protons, and that's where we got it from. Because there's no charge at all, we can say electron number is also 11. So how many valence electrons do we have in a sodium that's neutral? Well, let's see. So the first energy shell can only hold 2. That's a rule. So we're going to put 2 here. We have to keep going and adding electrons to each ring until we hit 11. So I'm drawing another ring. 1, 2, 3, 4, 5, 6, 7, 8 electrons right there. So we had 2 in our first shell, 8 electrons out here, so there's a total of 10 electrons. Well, sodium has 11, so I have to draw another ring and add the 11th electron. So if we did our math, first ring max it can hold is 2. We have 2 there. 8 in the second one because that's the max electrons it can hold. Now we have a total of 10 electrons, but sodium has 11. So we have to draw a third ring, and it is only going to get 1. So we have 11 total electrons. Again, the outer shell is the valence shell, and this valence shell has 1 electron right here. So there's 1 valence electron in a sodium atom. Okay, now let's try something with a charge. So let's do let's look. Let's do lithium. And we're going to do as a cation with a plus symbol up here. This plus symbol means that it has lost an electron. So if we draw this out, lithium has 3 protons. How do we know that? We look at the atomic number, that's 3. That tells us how many protons. If there was no charge here, lithium would also have 3 electrons. However, it bears a positive charge, meaning that it lost 1 electron. It lost a negative charge, and therefore it has an extra positive charge. So this case, we have 2 electrons. So if we draw and again, we're asking the same question, how many valence electrons are in this atom? We draw our lithium, and I'm going to put our charge right here. We only have 2 electrons because of our positive charge. So in this case, a lithium cation has 2 valence electrons. Let's do one with an anion. So we can do, I like magnesium. Well, no, we'll do chlorine. Let's do chlorine. So Cl negative. This is what we use if we have a ionic bond with table salt. So again, we're going to look at the periodic table. We know that chlorine has 17 because we're looking here. The atomic number is 17. That's how many protons it has. It would, if we did not have this charge right here, have 17 electrons. However, it's showing you that there's a negative charge. That's indicating that we have gained an extra electron. So now we have 18 electrons. Normally 17 if it's neutral, but because we have an anion, we have 18 electrons. And so we just fill our shells and determine how many valence electrons we have. So Cl negative, first shell holds 2. Second, every other shell past that holds 8. I'm trying to reach 18. So I'm putting 8 there. We have 2 from the first shell. We've used 10 total electrons so far, and we still have 8 more. 1, 2, 3, 4, 5, 6, 7, 8. So if we look at the valence shell of this chlorine anion, it has 8 electrons. And that's it for determining valence electrons. Reach out to me if you have any other questions.